Hi there, welcome to the last part of this series where we're going to talk about some advanced pre-processing methods. And what we can see here is RStudio, and this is a script that I've written in RStudio. I'm going to assume a little bit of familiarity with R as I go through this. If you don't know what RStudio and R are, then look online for tutorials in RStats. There are loads of ones out there, and it's a wonderful open source tool. What I've done in this script is essentially pre-process and reorganize the data files. And I've done this as simply as I can using two libraries which you have to preload. One of them is called dplyr, or dplyr, never quite know how to say that, and the other one's called string_r. And we're going to use functions from both of these libraries as well as the R base code. A force of habit, I like to clear the research environment, and this is good for debugging code. The number of times I've been trying to fix a piece of code only to find out that my code is perfect. The problem is that before I made it perfect, and when I had a mistake, I stored something here inside the environment, and that's never changed. And if I removed that and rebuilt it, everything would run absolutely fine. So it's good practice, I think, just to clear your environment. The next thing we do is set our working environment. This is where the data is. And we have four data files, which are all the CSV files from the task, which I've labeled MR, ML, WR, and WL for men attending to the men on the right, men on the left, women on the right, and women on the left. I'm going to explain count at the very end. And data frame, this is just creating a blank variable called task data. Now, the two things to be aware of within this script, and these are two general, principles or things you can do with computer programming. One of them is called a for loop. And a for loop basically says, I want to do the same thing again and again, but with a small change. It's the same thing as Task Builder when we use the spreadsheet option and we say, I want to do this trial again, but this time I want to change the picture. That's a for loop. And we can specify that in our code by saying for, in this case, j in 1 through 4. And that just means that there's going to be something called j, which is going to be the number 1 for the first loop, is then going to be the number 2 for the second loop, and then 3, and then 4, and then it's going to finish. And here we have a little if statement, and we talked about if statements briefly in Excel. This is a slightly more advanced version of that, but it's the same key idea. We're saying if j is equal to 1, so if j is true, then data is going to be women left, and we're going to use that as our data file, and the append is going to be the word women, which we're going to put into our final spreadsheet at the end. Now, we can also use, rather than just if anything else move on, we can use else if to set up a second condition. So we've now said, if j is not 1, what if j is 2? And if j is 2, do this. And if j is 3, do this, and if j is 4, do this. Once we've selected our data file, it looks inside that data file and it finds the unique participant IDs. The same thing that we did with our pivot table when we dragged private ID into rows. This then sets up our second for loop. We have a loop within a loop. The first loop goes between the 4 task nodes. This loop goes through each individual subject, and it uses this function called filter to essentially isolate one subject at a time. So we're going to filter only for one subject ID, and that's a new variable called ssData. The next thing we're going to do is strip ssData down so that it only has the things that we're interested in. Select means which columns are you interested in. Now I've got some columns here that would have useful information. And then in filter, this time I've used the string detect function because there are two kinds of response types, zone types, that use the word response. We've got the response button and we've got the response text area. So I need to use string detect to say anytime there is a zone type that uses the word response, I want to keep that, but all the other ones to do with checking the audio and the continue button, I don't care about that. It doesn't have any information that's useful to me. Once we've done that, The next step just uses the same logic again and again and again to isolate a piece of information and move that into a new variable which we're calling total. So what it does is it filters based on a display called check and a screen name screen3. So this is going to be, if you look back at the task builder, you'll see that is the tone on the left or the right, which was one of our first checks that we put into the experiment. Here we're just selecting whatever's in the column response, so it should be left or right. In total 2, so the next column along, we're doing the same trick. This time we're isolating what's in response when task and screen 6 are on. And this is again the next check. And this is after listening to the two conversations, the main audio file. It's saying, did you hear the person on the left or the right? Now this answer could be correct or incorrect. It could be left or right depending on which file you're listening to. So here we've added a little if clause that says if you're listening to 1 or 3, which is WL or ML, then the correct answer was left. If you're listening to MR or WR, then the correct answer is right. And so that little if statement's in there, and that tells the third column what to put in. We repeat this again, but this time for question 1. So we're looking at task screen 2. If they said yes, then the fifth column is going to be whatever they wrote down, which is task screen 3. If they said no, so here we've just used else, that column is going to be a blank, NA. The same thing again for question 2, and now we change the word task to control, and we do the same thing again. So we've ended up with 13 columns for our subject, which gives us check tone, the task check, the actual correct answer for task check, what they responded to question 1, yes or no, and if they responded yes, what did they write? The same for question 2, and if so, what did they write? And then the same for the controls. The here C means combine, so as well as having this 13 columns for one subject with all those variables, we're going to add in the ID code of that participant and who they were attending to, the men or the women. Now this is where the count variable comes in, because after this is finished, it gets to the end here and it just says count is the same as count plus 1. Count started at 0 when we opened the script, which means here count becomes 1, because 1 plus 0 is 1, which means you're going to put the data on the first row. Once this loops through the next participant, count equals count plus 1, so 1 plus 1 is 2, and that means you're going to put the data on the second row. And we do this is a very useful tool that I picked up from some engineers when you're working with nested loops, because when you have a loop within a loop, it can be quite tricky to use a good counter. So it makes sense to create a counter like this rather than using one of the variables that's changing with the loop, such as I or j. Once all of this is done, there should be a variable called task data, which has 50 rows for our participants, and it has 15 columns. And we've named those columns here, so it's clear what the data is in each column, and write.csv saves that out as a text file. And we can load that text file in JASP again, and this is what our new text file looks like. It's got who they were attending to, it's got the check tone, whether they got it, whether they said it was on the left or the right, the task check and task answer, did they say yes or no to the question, and if so, what did they write, and so on and so forth. So we've managed to write this script, and it organizes the data and gives us all of our information now in a small handy sheet. If I go back to frequencies and contingency tables, I can do the same analysis that we ran in the original study. So in this case, our row is attend, and question 1 is columns, and we get the exact same response that we got with the Excel file, which is obviously very reassuring. It's nice to see that. I'm going to add in the effect size here because we're going to do something else now, and I want you to pay attention. This started off as 0.56. I want you to see what happens after this next step. So we put in these checks to our data to make sure that people were listening through headphones. A couple different places we asked people, can you hear things on the left or the right? And it should be the case, if they are listening with headphones, they should be able to get that correct. So we can click up here and we can filter our data and we can exclude participants who got that wrong. Now I should say you shouldn't do what I've just done, where I've done the first analysis and I now start filtering people out to see if I can get a better result. That's not okay. That's totally unethical. I'm just doing that as a teaching tool. These kinds of decisions need to be made before you look at the data. And ideally, you should fill in something such as aspredicted.org, which is a website where you can fill in your analysis details, and it's time-stamped, so everyone can see what you were going to do, and it's very clear that you had planned this before you even looked at the data. It also means then that you can distinguish between confirmed analyses that you said you were going to do versus exploratory analyses, where you openly admit this is something we looked at afterwards after inspecting the data. And those kinds of exploratory analyses would require further independent replication. But let's say this was something we planned from the beginning and we hadn't actually looked at our data. So I can drag check tone into here and I can say check tone equals right, and I can apply that as a filter, and we can see down here at the bottom 50 rows, 41 have passed the filter, so 9 people were excluded. Let's now make an extra one, so let's also say I want to only include people where the task check is the same as the task check answer, as well when the control check is the same as the control check answer. And I'll apply the filter again. One more person has been excluded. So, and that one actually would be a very good one to exclude, because that person, clearly they heard the check tone was on the right, so they got that one correct, but then they got the next one wrong. If I now go back and look at my data, we can see that the Kramer's V has actually changed. It was originally 0.56, it's now 0.65, and the chi-square value has gone up, suggesting that removing those subjects has actually strengthened our result and given us a more significant effect. Obviously you don't want to justify this post hoc and suggest something like, well, obviously that's the right thing to do because my results got better. That's totally inappropriate. But it does suggest that if you had pre-registered this beforehand and you applied this, it seems like it was the right thing to do, to only include people who correctly passed your checks. Now, the one last thing you could do, and I think again this is another time to be very careful, and you definitely want to document these types of changes. Question 1 said, did you hear anything unusual? And that can be quite an open-ended phrase. Obviously, we can't say to people, did you hear the man walking through saying I'm a gorilla? So it had to make do, but in this case, this is a great example. This person said yes, and they responded, why was the one woman asking for tea? Well, that's not unusual, and maybe that's just my English bias. To me, that's perfectly normal. It's certainly not what we were expecting when we asked if something was unusual. So you could consider changing this result from a yes to a no, because we can see everything else here. When people say yes, they say I'm a gorilla. I heard continuously the man saying gorilla, the word umbrella, which could sound a lot like gorilla, so I think, yeah. These responses all say I'm a man said I'm a gorilla, I'm a gorilla. It's very clear with these responses that they heard the manipulation. This one response at the top, you could decide to exclude that participant, or you could decide to change their answer. Again, it's most important that you are clear about these kinds of changes if you make them. You have to justify them very clearly in the manuscript, and ideally you would do an analysis with and without the same change to see what effect it has. And if it doesn't have much effect, which in this case I doubt it will, then that should be fine. But there we go. Using our more advanced pre-processing script, we can organize the data really well, and it just uses a couple simple techniques: for loops, if statements, and just using the functions select and filter, and we can reorganize our data incredibly easily. Thank you so much for joining me, and I hope you found this useful. We're going to be running more of these over the year, so if there's something you particularly want to see, whether it's about memory, social influence, language, emotion processing, do let us know. And we're planning to build a variety of research methods courses, teaching you all the different kinds of tasks you can build in Gorilla, and going into different kinds of analysis as well. If you've got any comments about this or things you'd like to see in the future, you can follow us at Gorilla.sc on Twitter, or under Facebook you can find us at Gorilla.sc, or go to our website www.gorilla.sc. Thank you once again.